Welcome to our course, Engineering Mechanics, particularly Statics of Rigid Bodies. Let's solve some problems. First problem, determine the x and y components of each of the forces shown. We have a 50-pound force on the positive y and negative x-axis. We have measurements here, 28 inches to the left of the origin O and 96 inches above the origin O. The 29-pound force, 84 inches to the right and 80 inches above the origin O. And the 51-pound force, 48 inches to the right and 90 inches below the origin O. To get the components denoted by f sub x, let's take the cosine theta of the force F, in which theta is measured from the horizontal. So the measurements will come in here because we're going to use it to get the angle theta. F sub y is the sine theta of the force F, in which theta is also measured from the horizontal. For force with a magnitude of 50 pounds, theta can be obtained using the relationship of the opposite side over the adjacent side. Tangent theta is equal to 96 over 28. Theta is equal to the arctangent of 96 over 28. So for the horizontal component or x component or the f of x, for the force which has a magnitude of 50 pounds, so 50 cosine arctangent 96 over 28. And then for the y component, so 50 sine arctangent of 96 over 28. So f, let's store the values there, and then cosine, and then arctangent a over b. And then the other operation, we have the force F, sine arctangent a over b, in which f is equal to 50, a is 96, and b is 28. So therefore, 14 and 48. So therefore, f of x of the 50-pound force is 14 pounds and f of y is 48 pounds. Next, for the force with a magnitude of 29 pounds, so theta or tangent theta is equal to 80 over 84, and then theta is equal to arctangent of 80 over 84. So for the horizontal component, 29 cosine arctangent 80 over 84, and then the vertical component, 29 sine arctangent of 80 over 84. So f will be 29, a is 80, and b is equal to 84. So 21 and 20. So f of x or the horizontal component is 21 pounds, and the vertical component f of y is equal to 20 pounds. So for the 51-pound force, so theta is equal to the arctangent of 90 over 48. So for the horizontal component, f of x is equal to 51 cosine arctangent 90 over 48. Likewise, 51 sine arctangent 90 over 48 for the vertical or y component. So f is 51, a is 90, and then b is 48. So 24 and 45. So therefore, the horizontal component for the 51 magnitude, or the force with the 51-pound magnitude, is 24 pounds, and the vertical or y component is 45 pounds. We can also use the calculator function. We get the rectangular coordinates, the x and y, which are also component of a given force from the polar coordinates, r and theta. The r here is the given force, and then theta is the angle with respect to horizontal or x. So the first value we get is x. So for the 50-pound force, tangent theta is equal to 96 over 28. So theta is equal to arctangent of 96 over 28. So rectangular coordinates, and then f, and then the theta is arctangent a over b, in which f, the magnitude of force, is 50, a, so 96, and then b is 28. So the horizontal or the x component is 14, the y component is 48. So for the 29-pound force, so arctangent, and then f is equal to 29, A is equal to 80, B is equal to 84. So therefore, horizontal component or X component is 21, and then the Y component is 20 pounds. So for the 51 pound force, so F is equal to 51, A is equal to 90, and B is equal to 48. So X component is 24, Y component is 45 pounds. There's another way, the complex mode in the calculator, in the form R or force, and then angle theta, which will give a result of X plus YI. Or in the complex form, A plus BI. So for 50 pound force, here's your theta. So complex mode. And then F, angle for theta is arctangent. So A over B. And then force F is 50 or 50. A is 96, B is 28. So therefore, horizontal component is 14, vertical component is 48. So for the force with a 29 pound magnitude, F is equal to 29, A is equal to 80, B is equal to 84. So 21 and 20. So for the 51 pound force, F is equal to 51, A is equal to 90, B is equal to 48. So therefore, 24 and 45. Next problem. The hydraulic cylinder BD exerts on member ABC a force P directed along line BD. Knowing that P must have a 750 Newton component perpendicular to member ABC, determine first the magnitude of the force P and its component parallel to ABC. Here's the force P directed along line or member BD, and then it has a horizontal or component perpendicular to member ABC, which is a magnitude of 750 newtons, and then a component parallel to ABC or is acting on ABC, which is unknown, and then we have this alternate angle which is also 50 degrees. An angle here, so 30 degrees, then 30 degrees. And then the angle between the force P directed along line BD and the member ABC is 20 degrees. So therefore, we're going to use the 20 degrees here, 750. The vertical component is equal to P sine 20 degrees, because when getting vertical component in this form, we're going to use sine. Sine of P is equal to its vertical component. So therefore, 750 over sine 20 degrees, P is equal to 2192.8533, and you store it to A in a calculator. And then the force for the component parallel to member ABC is equal to P cosine 20 degrees. Cosine because the member is adjacent to the angle, which is 20 degrees. So therefore, we're going to use cosine. So A cosine 20 is equal to 2060.6080 newtons. So our answers are the magnitude of force P is equal to 2192.8533 newtons, and the component parallel to ABC is 2060.6080 and so on newtons. Next problem. Determine first the required tension in cable AC, knowing that the resultant of the three forces exerted at point C of boom BC must be directed along line BC. The corresponding magnitude of the resultant. So first, we're going to need the tension for cable AC, and then the resultant of the three forces must be directed along line or along member BC or along boom BC. And then the other unknown is the corresponding magnitude of the resultant, which is directed along line or along BC. So here are the given forces, 50 pound and 75 pound force, and the tension for cable AC, and the resultant or directed along BC. Alternate angles, so we have 35 degrees here. We're gonna isolate the problem on point C or joint C, so 65 degrees here. And we have the 50-pound force and 75-pound force and a 25 degrees angle between them. So we're gonna use this formula. It's like Pythagorean theorem for the components of the force. So our BC, or the resultant directed along line BC squared, is equal to the square of its components, the sum of the squares of its components. So r sub x and then r sub y, or the horizontal component denoted by r sub x and the vertical component denoted by r sub y. R sub x, positive forces, right-ordered forces, and then negative forces if it's leftward forces. So 75 sine 25 degrees. So sine, because it is the parallel to the, or opposite, its side is parallel to the x-axis. So sine, we're going to use sine 25 degrees. And then negative tangent, or tension of cable AC, and then sine 65 degrees as well, because the horizontal axis is parallel to the sine of the arc, or the tension of the cable AC, or the angle of the tension of cable AC, which is 65 degrees. And then for the vertical component or y component, tension for cable AC, cosine 65 degrees, positive, because this is above the origin C, and then minus 50, so it's a downward force, minus 75, downward force cosine 25 degrees. So cosine, because its vertical component is parallel to the y-axis, and it's adjacent to the angle given, which is 65 and 25 degrees. And then tangent 35 is equal to 35 degrees, so equal to the opposite over adjacent. So r sub x is equal over r sub y. Let's just substitute the formulas for r sub x and r sub y, and then divide both sides by tangent 35. Add both sides by 50 and 75 cosine 25. The tension for cable AC, sine 65 degrees. So therefore, we have isolated the variable for the tension for cable AC on the left side. I just rearrange it here and let's solve. So 75 sine 25 degrees over tangent 35 plus 50 plus 75 cosine 25 over cosine 65 plus sine 65 over tangent 35 degrees. So let's store it to A. So tension for cable AC is equal to 95.0751 and so on pounds. So we can solve for the component of the resultant directed along line BC. So for Rx, let's just substitute the value for the tension in cable AC. So 75 sine 25 degrees minus 9, or so stored at A, sine 65, so negative 54.4709 and so on pounds. So stored to B, the x component is negative, so we solve and it gave us negative values, therefore the x component is going to the left. Then our y is equal to the tension in cable AC, cosine 65 degrees, minus 50 minus 75 cosine 25. So A cosine 65 minus 50 minus 75 cosine 25 degrees. So therefore negative, store at C, so negative 77.7925 and so on pounds. So negative values hold downward. So we can get the value or the magnitude of the resultant directed along BC, or BC. Substitute the components, 54.4709 squared plus 77.7925. So square root of B squared plus c squared. So therefore, the resultant directed along member BC is 94.9672 and so on pounds. So our final answers for the tension for or in cable AC is 95.0751 and so on pounds, and the magnitude of the resultant directed along BC is 94.672 or 9672 and so on pounds.